Hello again, further students. In this video, we're going to continue looking at transition matrices, this time focus on the idea of a steady state solution. So there's a key idea with transition matrices that basically the further ahead you predict into the future, the more states you go past the initial state, the less the values will change. So often what happens when you go from, say, S0 to S1 to S2, you get pretty significant changes in the values. But as you get to sort of S5 and S10 and bigger numbers, the values are usually changing less and less. And eventually what will happen is they'll actually stop changing altogether. And the point at which they stop changing altogether is what we call the steady state. Okay, so the idea is that usually between about S15 and S30, but sometimes it takes a little bit longer, the values will stop changing, and so we can say that the steady state, or the long-term, state has been reached. And in order to find that and confidently say that we found that, we must calculate two consecutive, right? It's consecutive meaning in a row. Excuse my handwriting there. Two consecutive state matrices that have the same values, right? So if we can calculate, say, S49 and S50, and they're both giving us the same numbers, then we know we've got our long-term steady state. Okay, so let's check this out in an example. Incoming Year 7 students at Ringwood Secondary College choose either Indonesian or French as a language to study. In 2019, 130 students chose Indonesian and 140 chose French. Student selections vary from year to year according to the rule Sn plus 1 equals T times Sn. So a pretty standard matrix recurrence relation here, where the transition matrix is given by this, and S2019 is given by our column matrix 130, 140. So all the matrices have been set up. Okay, how many Year 7 students are expected to study each subject in 2023? Well, S2023, if we count this carefully, would be 4 years after 2019. So it would equal T to the power of 4 times S 2019. And so that would be, well, let's put it into our calculator and find out. So it's going to be, I'm just going to clear all this because it's a bit messy. The transition matrix, so 0.79, 0.21, 0.14, 0.86 to the power of 4 times 130, 140. Okay, and there we go. We get 111.9, 158.1. 111.9, and so 158.1. Now, again, the question probably not super clear about whether we should round or not round. Let's just say for the purpose of this question that we're going to say to the nearest whole number, that would be 112 students choose Indonesian and 158 choose French. All right, because remember that they were the labels on our matrix. It was Indonesian was the first element, French was the second. The next question says, in the long term, right? Now that phrase, in the long term, is really commonly used in these sorts of questions. And really what that means is we're looking for the steady state. Okay, so in the long term really means we're trying to find this steady state matrix. How many Year 7s will be expected to study each language? Now, let's think about what's going on so far. In 2019, we had 130 and 140 as our two values. 4 years later, we got 112 and 158, approximately. All right, so relatively significant changes. Yep, the Indonesian numbers have gone down by 18, the French numbers have gone up by 15. What we're going to try to work out is, if we can go far enough into the future, what will these values actually settle at? Right, so at the moment, we've done, it's still in the calculator there, that T to the power of 4. I'm just going to repeat that calculation and then just sort of change the power. Now watch this, if I go and work out the following year, right? So I've already got the answer for 2023, If I increase the power by 1, I'm going to get the answer for 2024. All right. Now, I've hit execute. You can see that the numbers are pretty similar, right? They've changed by, about 1 and a bit, right? But because they're still changing, we haven't reached a steady state yet, okay? What we have to try to do is show 2 states in a row that are the same. So I might try, right? So 4 and 5, 4 years and 5 years after the initial one isn't quite enough. Typically you can try, maybe 30 or 40 or 50. You don't want to make the powers really big because your calculator will take a long time to calculate it. Usually if you went up to 50, that would be enough. Right, so I'm going to say, let's go 50. Actually, I'll tell you what, just to make this a bit clearer, I'm going to delete that line just for now. So let's go 50 years into the future. Okay, that's given me 108 and 162 exactly. To confirm that I've hopefully got the steady state, what I want to calculate is the next number after that. They have to be in a row and hopefully show the same thing. And we've got it, right? So what that means is, and it maybe didn't take 50 years, but just to be sure, we went 50 years into the future and we've shown that these numbers have actually settled. If I go 50 years and then 51 years into the future, I've got the same value twice in a row, which means the steady state in the long term, this is what the numbers have actually settled on and they're not changing anymore. You don't have to do it, but you could even do a third calculation. You can see the numbers aren't actually changing, right? So now we've gone far enough into the future. We've reached this steady state. Now, 50 years ahead, so from 2019, that would actually take me to S2069. I'm going to show what I actually did because that's important in these questions. You've got to show you're working out. It was t to the power of 50 times the initial matrix, which was S2019. Right, that was equal to, just copying this off the calculator, 108 and 162. All right, the next one after that would be 2070, and we did that with t to the power of 51 times S2019, and that was also 108 and 162. So those 2 calculations there are showing how we've found the steady state. To answer the question though, how many will choose each language, it's 108 studying Indonesian and 162 choosing French in the long term. Okay, so that's an example of how the steady state works. We have to calculate far enough into the future that the numbers aren't changing anymore, and we have to show 2 in a row that give us the same values. All right, bye for now.